Okay, in our lesson today, we're going to work on classifying triangles. Okay, you remember those three-sided shapes. We're going to classify them based on both their angle measures as well as their side lengths, and then we'll use that information to help us find either missing measurements or lengths. Okay, so you got a fairly large set of vocabulary today, so pay attention, like I said before, for geometry. Knowing the vocabulary, because it's kind of a different math language, is going to be important. If you haven't started setting up flashcards, I'm going to really strongly, again, suggest you're doing flashcards to help yourself and make it a little bit easier on yourself in learning this content. All right, so let's dig into some of the vocabulary. So we know that a triangle has three sides, and we can classify those in two ways. One way is by their angle measures, and the other is by their side lengths. So let's look at a triangle here. We have a triangle with sides AB, BC, and AC, and we call those the sides of the triangle. Now I want to identify or remind you that make sure that when you name your sides that you're using our naming conventions. Okay, that would be incorrect if we do not put. If we forget to put this line above, then we're naming it incorrectly, or if we were to put arrow on the end of it, again, that means something totally different. The other thing we need to know about naming triangles, or when we see a triangle diagram, is that these letters that are at each of these corners, we'll call them, we actually call them the vertices. Okay, so a triangle has both three sides and three vertices. So let's start classifying them. Here, we've got what's called an acute triangle. Okay, you guys are probably well aware of this all the way back into grade school. So it's called an acute triangle because all of our angles are less than 90 degrees. Okay, and so these angles, like I said, are less than, right? Let's put that less than 90 degrees. Another triangle you'll see is what's called an equiangular. Equa meaning equal, and angular is talking about the angles. So we're talking about equal angles, and so you'll notice that they have three congruent acute angles, and those are marked by these arcs. Another one is going to be the right triangle. We have one right angle. There are no such thing as left angles or wrong angles. I get that question, it seems like every year. But right triangles will have one right angle. Okay, can't have two because you would have a triangle that would look like something like this. And it's not a closed shape, so it is not a triangle. Okay, and our last one is the obtuse triangle, where we have one angle that is greater than 90 degrees. Okay, and that's going to be here. So let's include that. So one angle is greater than 90 degrees. So how can we use this? Well, let's look at this example. So we have a triangle, or BDC, right? Triangle BDC, that's the one we're looking at. Okay, BD, DC, and BC are the sides. So we want to classify it. So let's look. Now we know this angle is 10 degrees. We know this one is 100. We don't know the measure of this angle here, but we honestly don't need to know it. Once I find an angle that's greater than 90, I can pretty much stop there because I know now that this has to be obtuse, okay, because the angle is obtuse. So you have an obtuse triangle. Now what if we look at these other angles, right? We want to classify now triangle ABD. So ABD, this one right here, this smaller triangle, we want to classify that one. So here's what we know. We know we have a 20-degree angle right in here, that little one. And we know this angle over here is 80 degrees, right? We do not know this measure. Okay, now there's another way you can find this, but let's go back and look. It's something we've just worked on recently. Angle ABD and angle CBD. So ABD, okay, ABD, and CBD. Okay, they form what's called a linear pair, right? Remember, two angles that are adjacent that form a line are called a linear pair, and so they have to be supplementary, which means they add up and equal 180 degrees. It's a bad 8. Let's fix that. There we go. So I'm going to write the relationship here, the supplementary angle relationship, right, in geometric terms, not algebra yet, that they're both equal to 180. Now I can substitute values, right? I'm going to use substitution to now get myself an algebra equation. And then if I solve that for my geometric variable here, the one I don't know, which is that measure of angle ABD, I'll find that it's 80 degrees. So with that information, I know that I have an acute triangle. All of the angles are less than 90 degrees. Okay, here's one for you to work on your own real quick. Go ahead and pause the video and we'll be back in a second. Okay, let's take a look at this. Right, we want to classify FGH, or sorry, FHG. Okay, could be named either way. So FHG, right? When we name a triangle, we just need to make sure we're using the letters. Now, the order may not necessarily matter, but formally, we typically try to go in alphabetical order if we can. We can't always do that. Okay, what I need to know is the measure of this angle here. Okay. Right now, we don't know it. We know what the combination of these two angles is, right? It's 90 degrees, which is a complementary angle, right? Because they add up to 90, that marking. So I'm going to use the complementary angle relationship, where if I add them together, they equal 90, and that's my geometric relationship. I'll do some substitution to write it as an algebraic relationship with my geometric variable, which I will again solve for, and you should get 60 degrees. So we have an equiangular triangle. All right, so let's go ahead and start talking about classifying triangles by their side lengths. So I want to make note here on an equilateral, again, equa meaning equal, lateral means side. So we're talking about equal sides here. In an equilateral triangle, we have three congruent sides. Notice they are marked with these single tick marks. So all those are equal. We can also have what's called an isosceles triangle if it has two sides are the same. This time I'm showing you could mark it with two tick marks. Just needs to be the same number to show that they are congruent. In a scalene triangle, notice there's nothing marked, meaning there are no congruent sides. Okay, and this is kind of what I was just talking about. You need to make sure that they are either marked or measured in order to determine whether they're congruent. Okay, things that are not marked or measured, we cannot make the assumption that they are congruent. So let's try one here. So we want to classify triangle EHF. Okay, here we're looking at E, H, and F, right? This is triangle right here. Okay, E, H, F. That's really bad. Sorry about that. So let's find out what we know. First thing we know is that these two sides are congruent. Notice the single tick mark. But there's no measure written here. Okay, but that's not going to be a problem because it's actually marked down here as being 10. So I know that the other side is also 10. Right? So if HF is 10, then I have what's going to be called an isosceles triangle because I have two congruent sides. Two congruent sides. Okay, now be prepared. Sometimes I'm going to ask you for reasons why. So you may be able to classify it, but then I want you to tell me why. Okay, because there are two congruent sides. Let's try to classify this one. EHG. So EHG is this big triangle on the outside, okay? I'm not going to draw around it because the last time I didn't draw very well. So let's think about what we know. We know the side lengths straight up for these two. They're just labeled as 12 and 11. Now the last side we don't know, but we know measurements for both of them. So if I use the segment addition postulate, I can calculate what the length of that side is. Okay? Now if we were doing a standard two-column proof, which I'll talk a little bit about later on, we would actually have to start by saying this, right? EG equals EF plus FG, and then I would have to write the algebra to it, okay? So if I know those measurements, I can tell you that since no sides are congruent, that triangle is going to be scalene. So no congruent sides. So let's let you work on one on your own here. So go ahead and pause the video for me. Okay, let's find out what you have found. You should have discovered that this was also a scalene triangle. Okay? Any questions on any of these, remember, please write them down, bring them into class, bring them up. You're probably not the only person that has these questions. So let's look at a new example. This one we're going to be using a little bit more algebra. Okay? So in this first step, I want to find the value of x. Right? In order to find these side lengths of this triangle, I'm going to have to determine what x is first. So I've got to write down some information that I know. So the first thing that I know, it's given, is that these two sides are congruent. So what I'm going to ask you to do is you start working through your assignment on this lesson. I want you to start doing kind of a two-column answering process, okay? Where you kind of go through setting up what you're doing, and then on the other column, kind of write down why you did that, okay? So in this first one, JK and KL are congruent. Well, that's given to me. It's marked already. So then if I go in, I say they're equal to each other, okay? That's just the definition of what's called congruent segments. Okay, so make note of that. That's the definition of congruent segments. Okay? When they're congruent, they're equal. This is the geometry. This is the algebra. Let's put that geo, and this is the algebra. Right? Geometric relationship, algebra relationship. So now I can go ahead and substitute in the expressions that I'm given. And then after that, it's using your basic algebra skills, right, of adding 10.7 and subtracting 2x from both sides. Okay, now I won't go through that process because I think you're pretty good at algebra. And you should end up with an x value of 8.5. Now, again, if you're having questions on the algebra, I want you to get with me really soon because those are some discussions we need to have before we get too much further in our geometry content. Okay, you're going to need those algebra skills, and we may need to do some practice on your own to get caught up if you feel like you're behind. So, now I know that measurement, remember, was 8.5. So I'm going to kind of underline this here so we remember. So now I want to find the side lengths. So now I'm going to go in, I'll just substitute the value into each of those expressions to find out what those measurements are and to see if I can prove the triangle that I thought it was. Okay, now when I saw these marks, I was expecting it to be isosceles, but to make sure I need to actually go back in and do the substitution by finding what x was to prove that that is true. And notice I have two sides that are the same length, so I do have an isosceles triangle. Okay? So I'm going to let you work this one on your own, try and do the same thing. Go ahead and pause the video here, and then we'll come back and look at your answers. Okay. So in this one, it tells us up front that it's an equilateral triangle. That's great. So I know the geometric relationship is going to be that those sides are all congruent. Once I move into my algebra, I'm just going to say, well, that's because of the definition of congruent segments, so I can rewrite that. And now I'm going to pick two of them, right? Two sides to use to solve for y. So I'm going to pick FG and GH. Okay, and you could have used GH and FH, or FG and FH, and done pretty much the same thing. And once I get my algebra set up, right, these are my relationships, this is the actual algebra after substituting, I'll go through the work, and you should end up that y is 7. And once I find y, right, I'm not going to have to do this for each of them, because once I find y, now I can go back and determine the lengths of those sides, and I'll just substitute the 7 into each expression to determine and find out that they are actually all congruent, which gives me that equilateral triangle, right? I need to make sure that they are all the same. Now this one, notice it wasn't marked for me, and that's why I needed to go back in and prove it. Okay, let's do a little application one here. We're looking at a steel mill, and it produces roof supports for buildings, and they do it by welding steel beams together, making equilateral triangles. Now, one, you need to know, what does it mean to have an equilateral triangle? Okay, that's our first place to start. So I know that equilateral triangles mean that each side is equal, right? And it tells me the length of each of those sides is 18 feet. That's great. Now, what can I do with that? Well, I know that I have a total length of steel beam that is 420 feet. So I'm going to have to come up with some things. I need to find out, if I made one triangle, how much steel am I going to need? So I'll start there, because I know that the perimeter is adding all the sides together, but in an equilateral triangle, I know the sides are all the same, so I can just make the perimeter at 3 times one side. If I do that, I find out that the perimeter of one triangle, okay, this is for one of those triangles, those beams, one beam is 54 feet. Okay, so now I need to figure out, okay, so if one is 54 feet, how many triangles can I get out of 420 feet? So I'll divide by the 54, right? For one triangle, it will tell me that I can get almost 8 triangles. Okay, but in the real world, I can't go with a part of a triangle for a beam, or steel reinforcement beam, so I'm going to have to truncate my answer to say that I can only make 7 triangles with a little left over. Okay, so we're going to finish this lesson out with some problems, some check it out problems that are in your note packets that you can do on your own, and then bring them into class, and we can review and go over those and make sure we're doing things the right way.